So there's a normal distribution of SAT critical reading scores, and we know that the mean is 504 and the standard deviation is 121. So let's jot that down. We know normal distribution, the mean mu 504, standard deviation sigma is 121. Okay. So okay. So what would you wait? Those are two separate. Oh, that's weird.
Yeah, it's two separate parts. The first part I got okay because you can use the stat disk for it and you'll get the right answer. But then, well, part
okay.
B is kind of confusing.
Sorry, I just assumed it was this. I thought it was the same score, but it's not the same score. It's like a different question. Okay, so part B.
Yeah.
Okay, so part B, how many would you expect to be greater than 550? So the thing we have to know is.
Can you please start by part 1, part A, I mean.
So we're gonna do part A. We're gonna do basically part B is like do part A and then do more. So I'm just gonna do part B. Okay. So yeah, so the question is about scoring higher than a certain number. Okay, so we know there's a normal distribution. Z-scores always has 0 in the middle. And then our data values X, the mean in the middle is 504. And then part B, greater than 550. So that means we have to mark off that point. And the X value there is 550. So that's the given information. Oh, and it's also asking about greater than, so I'll just mark that off. Okay. So the first thing we're going to do, which we know how to do, because we just talked about it, is find the probability that the data value is greater than 550. So we know how to do that. So first you find the Z-score, then you find the area / probability. Okay. So first we need the Z-score. So the Z-score is X minus mu over sigma. X value is 550, mu was 504, sigma was 121. Ooh, that does not work out nicely. I have to figure that out. Okay, so here's my little calculator. Okay,
I got 0.380.
550 minus 504 over 121. Okay. Let's see. So for a Z-score, you can take it to 2 decimal places. That should be fine. So 0.3. Okay. Next. So okay. So we fill that in. And now we just find our areas. So StatDisk tells us 0.38, plug it in, and we get our probabilities. So because the question asked, oh, let me go down, okay. Greater than 550, of course, greater than is to the right. So to the right, 0.35, but it's gonna be rounded up, so 0.3520. And that's the one that we need. So that the probability that a value is greater than 550, oops, is gonna be 0.3520. Now that's the typical way to ask this question. That's not what this question is asking. So if it were a part A style question, it would say what percentage is blah, blah, blah. So how do you, given a decimal number, how do you find a percentage?
You times it by 10. I mean 100.
Yep. So as a percentage, this would just be 35.2%. Yeah, times it by 100 or just move it decimal point 2 places to the right, same thing. Okay. So that would in effect how you would answer a part A type question. But this asks something slightly more complicated, which says, if there's 1,000 scores, how many would you expect to be greater than 550? So how many out of 1,000? So 0.3520 is the probability that one score is above 550. So if you want to know it for 1,000, all you do is you multiply. So that's going to be 352. So notice that another way of saying this is that, remember our old definition for probability. Well, our first definition for probability was that sort of the number of things we're looking at, which is like the frequency over the total number, gives you your probability. So in this case, the frequency, we're trying to figure out the frequency. The frequency we don't know, let's call that F. And then the total number, where we're told out of 1,000 people. And then it's got to be this probability. We know the probability is 0.3520. So if you want to find how many out of 1,000, so from our definition of probability, you can see just it's 0.3520 times 1,000. So that's another way to think about how do you get this answer. This goes back to the definition of what is a probability. So it's a little sneaky, but that's how that one works.